All right, guys. So, we've been working on percents, and in the last video, you learned about the percent of change, whether it be an increase or a decrease. So today what we're going to talk about is we're actually going to talk about something called markups and discounts. This is something that you're going to run into in your everyday life when it comes to shopping pretty much anywhere. You always are going to have sales, which are discounts, or markups where things are marked up from what the store actually buys it for. So these are really good things to know about. So the first thing we're going to work with is the markup. So in order to solve what a markup is you have to think about it this way. So you have the store's cost, which is the amount that the store buys the product for, plus the markup, so the amount of increase in the price, and then we get the selling price, which is the amount the store sells the product for. Okay, so this is basically how markup works. All right, now we can use that formula we learned for percent of change to actually figure out the equation for the percent markup. So we learned that the percent of change is the percent equaling the amount of change over the original amount. To transition into the markup is the actual markup, however much the differences between the selling price and the store cost over the store's cost. All right, so let's see how this works. So we have this problem. The cost to manufacture a watch by a company is $30. Calculate the markup percentage when the watch is sold at a price of $33. All right, so we have to think about how much. So this is our, the cost price is the same as the store cost. Okay, so this is what the store buys the product for. And we want to figure out how much the item has been marked up. So we need to figure out, we need to do 33 minus 3. Okay, so our markup then is going to be $3. We have 33 minus 30 over the store cost, which is 30. So then we figure out that 33 minus 3 is 3 over 30, which we can reduce to 1/10, which is the same as 10%. All right, so in this case, and I'll just show you this how it works. So in this case, the markup is 10%. Okay, so we would say that the store marked the price up by 10%. Okay. All right, so here's another problem. We have a school store sells pens. Each pen costs the store 79 cents. The store then marks up the price 65%. What is the selling price of each pen? So you have to think about that formula again, the markup over the store cost. So the store, we know that we have some selling price. We don't know what the selling price is. We have X minus 0.79. And we know that's over the store cost, which is 0.79 again. And this whole thing equals 65%, or I can say 0.65. All right, so now we just simply solve for x. So in order to do that, we need to get rid of this bottom 0.79, so we can multiply each side by 0.79. So this will go away, and we're left with x, or my store cost, or my selling price, excuse me, minus 79 cents equals 0.65 times 0.79 is 0.51, and it's actually 5135, but I'm just going to round it to 51. Since we're working with money, we know that money is only to two places. Okay, so now we need to add 0.79 to both sides in order to solve for x. This should all be familiar to you since we've been working on equations all year long. These go away, and x is going to equal $1 or 1.3, which in this case is $1.30. So what is the selling price of each pen? $1.30. All right, so make sure you know the different, or know how to manipulate this particular formula here. If you get how the formula works, you can solve practically any problem in order to find the selling price or the markup. Okay. All right, so from here we're going to transition over to discounts, or um, so we can also use percents to calculate the price of items on sale. So how discounts work: we have a regular price, our original price, it's pretty self-explanatory, minus the amount by which the item on sale is reduced, the regular price minus the sale price, so we have the discount. Okay, and then from there we get the sale price. Again, we can think about how our percent of change formula works. Same sort of thing with the percent of discount. We can add percent of discount equals the discount over the regular price. So the discount would really be the selling price minus the sale over, or the regular price minus the selling price over the regular price. Okay, so let's see how this works. So we have the sale price is $61.20, and the regular problem is the regular price is $68. We want to solve what percent discount you're getting. So we have 68 minus 61.20 over, remember it's over the regular price, so over the regular price, which is 68. All right, and that's going to equal to 6.8 over 68. Divide 6.8 by 68, and you get 0.1, or 10%. So this item has a 10% discount. All right, so what I'd like you to do is figure out in your WIS tonight, please figure out what percent discount you're getting for an item that has a sale price of $3.60 and a regular price of $24. Okay, so find the percent of discount. Okay, all right. So this is very common when you're talking about different items. For example, I have a big four-wheeler that is going for a price of $1,000, $299, and I know that it's 70% off. So I want to figure out what the new price is. So just like in the markup problem, we can figure this out by plugging things into our equation. So I know that the original price is $1,299, and I don't know my sale price, so I'm going to call that X, And I'm going to put that over the original price. And I'm going to equal that to 70%, or in this case, we want to keep it on the decimal, so 0.7. Again, solve for x. So multiply both sides by 1,299 to get rid of that denominator there. And then we have 1,299 minus x equals 909.3. Subtract 1,299 from both sides. Now in this case, you're going to notice one thing. And what you're going to notice is that you actually have a problem now that has a negative x, because these go away, so we're left with a negative x equals, it's going to be negative 389.7. Now, obviously, we know we can't have, we know that this doesn't work, so remember there's like an invisible -1 in front of that negative x, so it's, you're dividing each side by -1, so then we get x equals positive 389.7, or in this case, our sale price is going to equal $389.70. Okay, so I'd like you to do that same type of problem in order to find out what the new price of this art kit is. So the original price is $54. It's marked 40% off. Find out how much the sale price is in your whisk tonight. All right, so I know that was a lot of information with markups and discounts. A lot of it just stems from the percent of change, so just think about it that way and it should be a little easier for you. If you have any questions, please bring them to class tomorrow. Otherwise, be prepared to work on this tomorrow as a class, or in class. All right, thanks guys.